Good morning to one and all present here. Myself, A. Sri Krishnan, Assistant Professor, Department of Mechanical Engineering at Dr.M.G.R. Educational Research Institute, heartily welcome you all to ATAL 5-day Faculty Development Program on Augmented Reality, Virtual Reality. We are extremely delighted to have in our midst an unique blend of educationalists from reputed universities and specialists from industries who will be sharing their unique perspective on this fast growing field of augmented reality and virtual reality research field over the past next 5 days. We are indeed privileged to have Dr. Karunakaran, Professor, Mechanical Department at IIT Bombay as a chief guest for the inaugural session. A professor who has many distinctions right from his college days at Anna University to winning many laurels, especially from German-based automobile giants, and has been associated with plenty of honorary assignments. The department is extremely happy to welcome you, sir, for today's program. Then we have in our midst a very dynamic personality who has been constantly motivating us to achieve our goals. She is none other than our beloved Vice Chancellor, Dr. Geeta Lakshmi ma'am. Ever since she has been joined us our university, she has been constantly motivating us to achieve our goals. Ma'am is from medical sciences, but we have always admired her for her energy and enthusiasm in guiding us in various domains of engineering. It is always an honor to have you see you, ma'am.
Yeah.
Then we have our beloved Joint Registrar, CDC cell, Dr. M. Ganeshan, a former beloved head of the department. He is a man known for his sincerity in everything he intends to attempt. It is always a blessing to have him with us to give felicitations. We are always looking for his guidance. Welcome, sir. And finally, last but not least, the captain of the ship, Dr. K. Rajan, Professor and Head, Department of Mechanical Engineering, without whose support, the FDP would not have seen the light at the end of the day. Thank you again, sir. Now, I request our head of the department, Dr. K. Rajan, to deliver his welcome address. Sir.
Happy morning to all. Happy morning to one and all present here. On behalf of the Department of Mechanical Engineering, I am happy to welcome our respected and honorable Vice Chancellor, Dr. S. Geeta Lakshmi ma'am, for this 5 days FDP program on augmented reality and virtual reality. I would like to welcome our chief guest, Dr. K.P. Karunakaran, Professor IIT Bombay, for this 5-day ATAL FDP program. I would like to welcome our Joint Registrar, CDC, Dr. M. Ganeshan, sir, for this event. I take this opportunity to welcome all the eminent speakers and participants from different institutes of excellence during all these 5 days to follow. Department is indeed so happy to have you all together for joining this FDP, and a big thanks to each and everyone present here. Enhancing skills through faculty development programs is rather one of our institute mission statements. On that note, I would like to say, whether it is for our students or for the faculties, our management always tries their best to ensure the institute mission is in constant process of being achieved. The FDP is conducted along with the ATAL and patronage of our research institute. The department feels privileged and honored to have the fullest support from our Honorable President and Vice President, Registrar, and all other office bearers. The crux of this FDP will be the use of digital technologies such as artificial intelligence, augmented reality, and virtual reality that is being increasingly adopted after the outbreak of the COVID-19 pandemic. The program provides an opportunity to perform research in the area of augmented reality and virtual reality for various domains. The sessions will be handled by the industry's experts and professionals from premier institutions like IIT and Anna University, who are experts in the area of augmented reality and virtual reality. I request all our faculty friends and different institutes to make use of these 5 days to the best of their abilities. Now I request our Honorable Vice Chancellor, Madam Dr. S. Geeta Lakshmi, to deliver the inaugural address. Thank you, Ananda.
Thank you for inviting me for this Atal 5 days FDP program on by M.G.R. Educational Research Institute, which is one of the premier institutes in India and in Tamil Nadu, catering to many students, particularly socially, economically weak students, up till PhD and training in all skill development. Thanks to the philanthropist, our chairman, AC Shanmugam, and President ACS Arun Kumar, for educating the society. To start an educational institute is really a difficult one, but to maintain and sustain and go ahead in all field is definitely the people around us are fortunate to have such a kind of person. And I welcome Mr. Karunakaran, IIT professor, who would be delivering today's expertise in augmented reality. And of course, I would like to say, though I come from a medical field, but this virtual and augmented reality always helps in medical field in various aspects, starting from educating the students right from their first year, anatomy and other procedures, where they can see, view, because when I was a student, I used to do my dissection with the real dead body, but nowadays it's become a virtual, augmented reality has come into place, where you do it by having this augmented reality with virtual reality. So in various other fields also, other domains in engineering and whatever it is, this would be an experimental one before launching a new venture or a new product. This would be of help, and we can view the world on near our own place when we know the other, the real part of it, and then we make it as an augmented reality which comes near to us. So this would help us, but it would definitely have its effect like disadvantages also. We have to work on how to overcome these disadvantages. And I want our mechanical engineering department to collaborate with the IIT and Anna University, with the professors who have come today, to have a skill training and do more research on this augmented reality. Thank you one and all, and welcome our guests who have been going to deliver their experience, knowledge, and future expectation, which would come through to the 5-day program. Thank you.
Thank you very much, ma'am, for your kind words of inspiration and encouragement. Now I would request our beloved Joint Registrar CDC, Dr. M. Ganeshan, to deliver his felicitation address. Sir, over to you.
So good morning to all. So I am Dr. Ganeshan, so Joint Registrar in Dr. M.G.R. Educational Research Institute, taking care of the curriculum development and outcome-based education. So I have great pleasure in welcoming our Vice Chancellor, Dr. S. Geeta Lakshmi, who is inaugurating today's program. Chief guest of the day, Dr. K.P. Karunakaran, Professor, Department of Mechanical Engineering, IIT Bombay, and all the participants from various academic institutions across India. So I'm very happy that the Department of Mechanical Engineering at Dr. M.G.R. Educational Research Institute is organizing Atal FDP, sponsored by AICTE, from 4th October to 8th October on the topic Augmented and Virtual Reality. So I would like to give a brief about the university to the experts from outside and also for the participants from various universities. So the Dr. M.G.R. Engineering College was started in the year 1988, and it was under Madras University and Anna University till 2002. And 2003, we got deemed university status from UGC under Section 3. And from 2003 onwards, we are deemed it to be university. And our university was started by Dr. A.C.S. Shanmugam, so who is a philanthropist and also an educationist, and is well known not only in Chennai, all over India. So and later now we are all working under the leadership of Mr. A.C.S. Arun Kumar, so who is the president of the university. And our university is having 12 faculties functioning. So like engineering and technology, we have medical science, we have dental science, we have humanities and science, we have architecture, we have management studies, we have computer applications, we have education, nursing, hotel management and whatnot. So like this, it's spread over number of that is disciplines and faculties we have. And about our Vice Chancellor, already they have introduced, she is also very familiar in the academic side throughout India, and she is the driving force in our university for all our academic activities. So regarding this FDP, so this is the second FDP the Department of Mechanical Engineering continues successively conducting, sponsored by AICT, that is Atal FDP. Last year also they conducted on waste management technology, and this time they have also selected the topic augmented and virtual reality. So generally about this event, it is very, very important at this point of time. The higher education institution in India, actually it is said to reach an inflection point. So now the usage of digital technology in teaching learning process, already it's becoming a common phenomena in all the institutions in India, not only India, throughout the world, thanks to the pandemic COVID-19. So it is a blessing in disguise. Otherwise, we would not have you use these technologies and ICT tools to this extent for the last maybe nearly 2 years. So now the forces of augmented reality and virtual reality are pushing the higher education into experiential learning activity. So that only I can tell about that. And also technology has been a great boon in taking education out of the clutches of the chalk and talk, and also the remembering method of learning. So that is the lowest level of learning in the Bloom's taxonomy. So now we are going to the other levels like level 3, level 4 with all the digital technologies. So students now have access to vast amount of data and learning materials, while the teachers are increasingly playing the role of acting as a facilitator. So education has been customized according to students' need. So teachers are creating online classes, online lessons to address particular learning gaps and strengthen the understanding for certain topics that need deeper learning intervention. So to top all these things, augmented and virtual reality technologies are being deployed for optimizing learning outcomes through the use of simulation, 3D imaging, and advanced audio-visual effects. So I congratulate the Department of Mechanical Engineering and the coordinators of the FDP, Dr. K.R.G.Kumar and Dr. Jaiseelan, for having selected the right topic in the right time. So I am also very happy that we also applied for a lab to set up a lab in the same area, augmented and virtual reality. And also we have got the approval also from the AICT for setting the lab. Just I would like to inform all the participants in this time. So I wish all the participants of the FDP to interact with the expert speakers and make use of the sessions lively and clarify all your doubts regarding the implementation of the new technology, AR and VR. I wish all the best for the organizers and also all the participants. Thank you, one and all.
Thank you very much, sir, for your again kind words of encouragement. Now I would request Dr. A. Manoj Babu, Deputy HOD, to introduce the chief guest of the day, Dr. Karunakaran. Manoj, sir.
So, good morning to one and all those who present here. I feel very happy and feel very privileged to introduce our today's chief guest, Dr. Karunakaran, who is working as a professor in the Department of Mechanical Engineering, Indian Institute of Technology, Bombay. Basically, Sir has completed his BE in Harness from College of Engineering, Anna University, Gindi, in the year 1984. Then he has completed his graduated in M.Tech from IIT Madras in the year 1988. Then he has completed his PhD from IIT Kanpur in the year 1994. Sir, research interest is basically about rapid manufacturing, CNC technology and automation, computer graphics for SCAM applications, rotary wing micro aerial vehicles, and helicopters without tail rotors. And Sir has received many awards, such as 1 or 2 awards, if I want to tell you that, like he has won Dr. P.K. Patwardhan Technology Development Award at IIT Bombay in the year 2003, then Humboldt Fellowship in the year 2000. Then he has won INSA DFG Young Scientist Award and visited Germany during April to June 1998. Then he has won Wilkinson Sword, a prestigious rolling trophy in HAL, given to the best management trainee in the year 1985. So also he has won KCP Endowment Award given to the best BE project in Anna University, Madras in the year 1984. And also he has he is the member of the editorial board of International Journal of CAD/CAM. He was a consultant to Bacom Tech, San Sebastian, Spain during July 2003 and guided them in configuring a volumetric NC simulation system. And he was a consultant in CNC and RP at the Mercedes-Benz Technology Center of Daimler Crystal AG, Germany during June to July 2000, and have reviewed papers for several international journals. And also he has done some honorary assignments as a member of steering committees of Department of Information Technology, DIT, then served in several committees of All India Council for Technical Education for project selection, accreditation, and approval of PG courses, member of an expert committee of a National Institute of Design, Ahmedabad, to advise them in setting up high performance visualization and rapid prototyping facilities in April 2004. This project was funded by DST, World Bank, and ICSI. Have served in many faculty selection committees in various engineering colleges. And he has published more than 3 patents in various areas. And as far as publication is concerned, he has published more than 10 international journals, more than 5 national journals, then he has attended more than 25 international conferences, then more than 5 national conferences. Then he has he participated as an invited lecturer in more than 25 invited lectures he has participated. Then short-term courses he has attended, many short-term courses he has attended, and many books he has published. And these are some things like to know about the Sir. And still there are many things are there to tell about him. But after this, I stop this actually. And we are very happy to have you with us, Sir. And we are very happy to have Sir for this 5-day FDP program. Thank you, sir. Thank you all. Thank you, Ananda.
Thank you. Now
I request Sir to take over the stage and give the special address. Sir, it's all over to you, sir.
Thank you. Thank you very much for this nice opportunity to be back in Chennai, not physically, but virtually. I think I should move this. The ribbon, is it hiding? I don't think so. It's okay. Okay, so in programs like this, knowledge upgradation is certainly one very important thing, but equally important are the other things like networking, because this is the program in which various experts talk to you. So you can note down their contact details. Similarly, you are also with other participants. So it is nice to note down all their contact details so that you create a network for your future activity. So according to me, in all these programs and conferences, networking is equally very important. And for me, I would like to use this as an opportunity to introduce myself, because we cannot work in isolation. We need people from various domains. We need you people as colleagues, as PhD students. So, or some collaborations are possible. So I take this opportunity primarily to introduce our research activities to explore whether we can have some dovetailing at some point. As Professor Ganesan mentioned, he used the word blessing in disguise, which I have also written. Like Corona, we have gone through many catastrophes or calamities. So we will pass through this also, and probably it is on its way out. Like Shani Bhagavan, when he goes, he does some good things. This epidemic has really showed us many facilities and opportunities we were failing to make use of. One of the important things is this type of online meetings and avoiding physical travels. In an event like this, if I had to participate in the past, I would have to plan at least 2 days and then travel all the way. So all that wastage has been eliminated. It also has highlighted how poor is our network. So I'm very sure the infrastructure will be focused and will have much better bandwidth of communication so that we can see each other as the presentation is going on. So in this context, the topic like virtual and augmented reality is very, very useful, because what we see, even if the video will work, is 2D. If we can have a virtual reality environment, we can actually see each other in 3D. We can even, use sense of touch and, other senses to interact in a much better way. So in future, probably we may be able to interact in 3D and in other senses. So in that sense, I would feel that this program is very, very apt at this juncture. Okay, so I've been already introduced, my biography was told to you. So I'm a graduate from Anna University in 1984. Then I joined Hindustan Aeronautics Limited, and I was lucky that HAL allowed us to go for MTech in IIT Madras. So that is how it started. Otherwise, I had to, take up a job soon after my undergraduation. So this job gave me 2 degrees. I could also do PhD in IIT Kanpur. I didn't know a single word of Hindi when I was posted in Kanpur. I thought I would return it the next week itself, but somehow I carried on and I continued there for almost a decade. It was a period of training program for me. The job in HAL, the PhD in IIT Kanpur, both were great training programs for me. So in IIT Bombay, we focus on 3 areas of research. When I was in HAL, I was specializing in manufacturing areas. I was lucky to work on India's largest CNC machine, which was used for milling aircraft wing panels, something like 6 meters long. So the machine itself was 17 meters along X traverse and commensurate sizes in other axes. It was a 5-axis machine with very interesting kinematics. So that machine became an inspiration for me to do PhD in IIT Kanpur. So in Kanpur life, I specialized in manufacturing areas, particularly CNC technology. I also got exposed to sheet metal manufacturing and outsourcing through subcontracting activities and things like that. So after coming to IIT Bombay, I added additive manufacturing. So it was in 1987, the first 3D printer was introduced in the world. And that was the time I was doing literature review for my PhD in IIT Kanpur. So I brought it to the notice of my guide, and then he wrote a big proposal. He, in collaboration with IIT Bombay, got a big proposal of something like 10 crore, through which both institutes bought 3D printers. We didn't have a lot of money. So we bought FDM, fused deposition modeling from Stratasys, and then some silicon graphics workstations. So that is how we started. So I started with additive manufacturing in the year 1996. I joined Bombay in Bombay IIT in 1994. Within 2 years, we were able to procure and set up the facility here. So here I added additive manufacturing. So my area is actually called hybrid manufacturing, HM, because it is addition, subtraction. We started with addition and subtraction, then subsequently we added many more to it. Okay, so drone has been my passion all the time. It was not drone, essentially you can say flying. Flying has been, I think it is passion for it, not only to me, but I was able to follow it up on and on. Initial period was only manufacturing, but then back of mind, I've been always looking for some opportunity. So we started with convention. I was always very particular about vertical takeoff, because the regular plane, the infrastructure and the land required is very high. So I was all the time keen on vertical takeoff system. So we started with normal helicopter. Then finally, way back in very recently, about 3 years ago, I switched over to the drones. So I'll talk about it for some time, probably till about 10:45. I'll talk about my various research interests. That is the purpose is to expose what kind of activities go on in IIT Bombay in my lab, so that we can engage in future. So drone, hybrid manufacturing, and very recently I have started a new area which I title as green hydrogen mobility. So essentially we are talking about producing hydrogen in a green way using solar and windmill power, and then use them for mobility application. That again is linked with drone, because my ultimate goal is to develop huge drones which are powered by hydrogen fuel cells, whose hydrogen is produced using these sustainable energy sources. So our philosophy of working is dare with care, and there are some keywords which describe our research. One word is discrete, another word is adaptive, and the third word is hybrid. Okay, so discrete because in most of the applications, although you may design the object with very smooth geometry, going up to the level of NURB and other free-form surfaces, ultimately in real applications of manufacturing, such as virtual reality or additive manufacturing, we deal with, thanks. We deal with triangular geometry or tessellated geometry. So that's what I mean by discrete. So when you try to discretize a surface, you end up with several triangles. So we are also talking about adaptivity. Put larger triangles at some place, put smaller triangles at some other places. Okay, so we would like to do adaptivity. So discretization, adaptivity, and hybridization. There are many technologies which are competing with each other, and we try to make them work in a complementary mode. So that is our philosophy. So I'll quickly go through one by one. So we are probably the earliest in India to develop a drone, because way back in 2005 we started. At that time, this type of drone is unheard of in India. So we received a grant of rupees 10 lakh from AR&DB, and then we developed this drone and then demonstrated it in Agra Air Base way back in October 2007. And you can see that's a very, very rudimentary device. In those days, this requires typically blades which are of opposite pitch. they were not available. So since I had a 3D printer in my office, I used my 3D printer and reverse engineering, laser scanning. So we use laser scanning to scan a right hand blade, and then mirrored to get the CAD model of the left hand blade. So we were able to print both of them in our 3D printer. So the blades were 3D printed. And in those days, today, anybody can, buy the necessary controllers and, assemble and then build a drone in about 20,000 rupees. And the moment you assemble, it flies. The whole thing is, available with all sorts of sensors packed into one chip. We use a chip called a Pixhawk. Okay, but in those days, it was not available. So we had to buy a microcontroller, we had to buy accelerometer, we had to buy gyro, we had to write a Kalman filter software, then we had to add all other sensors like magnetic sensors and all that. Finally, we had to build it. So that is how we built it. But today, things are much better. So thanks to this movie, 3 Idiots, which came in 2008, that movie gave a lot of promotion to this technology, which motivated a lot of youngsters to work in this area. Today, if you look at any drone industry, most of them are run by very young engineers. Most of them are less than 30 years. Okay, so subsequently, I gave up drone. Then because I was a drone, even today, it is a very small item, more like a toy. You put a camera, use it for surveying and other applications. I was keen on a manned drone. In fact, we engaged with Fortis Muller Hospital in Adyar. I have a good relationship with Fortis Group. They are interested in developing some kind of air transport system for quickly transporting the donated heart from one city to the other. So my ultimate goal is this. We would like to develop a huge drone which can pick up the heart donated by a brain dead patient and carry it over probably 200, 250 kilometers and then deliver it in the roof of the other hospital in a big city which has the facility for the transplant. So that's a very high goal. Let it take time, but I'm very sure with systematic approach, we will be able to do. We have been making a lot of baby steps towards it. Every step is a very baby step because we have to be very, very careful. So this is our first flight on 17th of February this year. This is me sitting in my drone. This is a Corona beard I had. This is my team. The interesting thing is we built the whole thing out of stainless steel. When you talk about people, when you talk about drones, people always talk about aluminum or graphite fiber and all that. But we decided we are conscious about cost. This entire structure, you'll be surprised, we were able to fabricate with just 80,000 rupees, which is very, very low. And because we used 10 by 10, 1 millimeter wall thickness stainless steel tubes. We went through a lot of FEA optimization. Finally, we arrived at it. And we were also very conscious about safety. So we ordered a guard for the propeller. So this became a beautiful product. So it's being taken out. So right now we are testing empty in front of the lab. Then I sat on it. So I'm going there to sit. But I was sitting there as a livestock. The pilot was flying in from the ground. So this is the first manned drone in the country. So the boy here, he is flying it with the remote control, and I am sitting there as a livestock. Now I'll go to the next video, which is far more interesting. This was the test done on August 3. This time I'm the pilot. I am sitting in it and I'm flying it. You will notice that we have put 4 footballs, which are actually the landing gears. Are you able to hear the voice? Sometimes voice doesn't go through. Can one of you reply, please?
Audio is not there.
Okay, it doesn't matter. Video is enough. Thank you. I was able to fly non-stop for 8 minutes. Yeah, this will go on for 5 minutes, so we'll continue. So before we make the full drone, so this is today able to fly for about 8 minutes. Now we are completely revamping our battery system. In a battery-based system, one will be able to easily get about 25 minutes at least. We are talking about 200 kilometers and almost 4 hours of travel, or at least 3 hours. So we are also developing a DC generator set, which will be in this, there will be a petrol engine, which will generate the mechanical power, and an alternator will convert into AC, which will be further converted into DC. So we are developing that system currently, because it has to be a hybrid system. So you can see that even our drone is going to be a hybrid drone. So before we make the full version, we normally make a scaled version and then test it thoroughly before we go to the final one. So I'm flying the scaled version. This helps in identifying a lot of flaws in the design and correcting it. You will also see something very interesting here. It's the same pipe we took, 1 millimeter wall thickness, 10 by 10, but we did a lot of hollowing using laser cutting in order to reduce the weight. Now you see that the propeller is facing upward, and I was sitting in this location. The propeller is hardly about 1 foot away from me. So the next version, what we are doing is we are flipping the top rotor, taking it inside, and we are also putting some covers. So the safety is very important. That's why we are very, very careful and making baby steps each time. Okay, now that is about drone. Our ultimate goal is also to develop a 3-seater, which will act as an ambulance. This particular rectangular configuration is very, very ideal for that type of application. So we'll have a single seater as well as an ambulance. We are not looking at civilian mobility for taxi application, because that will never be approved by the government, and no country is having that because of the safety and security reasons. Okay, now I'm coming to our additive manufacturing activities. We have built, this is the culmination of my 25 years of research in metal additive manufacturing. Our technology is called a hybrid layered manufacturing. You may recall 3 keywords I mentioned that define our research activities: hybrid, discrete, and adaptive. So hybrid layered manufacturing is the activity we started way back in 96 or 97. So since then, we have been getting a lot of funding from various agencies, and we were focusing consistently. So this is the outcome of 25 years of time and almost 16 crore of investment into that. So that has resulted in a beautiful machine which is under construction in Bangalore and in finishing touch. Sorry?
Name.
Okay, here also voice may not be.
Dr. Rajan, please mute your.
Okay, so this is the machine we have built in Bangalore. I have hired a 2 BHK house in Bangalore, stationed 2 students since March, and I visit Bangalore every week and spend 1 or 2 days since June in order to supervise this activity. So you can see there's a very, very professional machine. On the left side, what you see is a vertical machining center. On the right side, this is again a vertical machining center, but a stripped out version of it. Only the vertical column of the same machine we put here. While left side is a full-fledged VMC, right side is only the vertical column to give it the Z-axis, because these two are connected by a long beam which have to be lifted. So we have 2 lead screws on either side. They work in collaboration to lift and lower it. This uses a Siemens 5-axis CNC controller. It's a 5-axis machine. Any 3D printer does not need more than 2.5 axes. You either move in XY direction or you move in Z direction, but we have gone for a 5-axis system. For want of time, I will not go into the details of it. I think audio is not there, right? So I'll augment it. I'll talk about it. So this is a 5-axis machine. You can see that A and C axis move here. And here you have several slides. Each slide will have a tool. This is a milling head. And in one, we will mount an inspection camera. Another will be a MIG deposition system. Third will be a laser deposition system. Then we'll have a preheating system. We'll have a hammering system for stress relieving. So this is more than 3 meters long. So the required tool can come down and then it will work on the part. The part will be mounted on the rotary table. Not part, the substrate. On the substrate, deposition will take place. So this is how this machine will work. It can be used as a regular milling machine as well. Okay, so this is the closer view of this machine. So as you can see, if you want to produce an impeller, as it is shown here, we use a MIG deposition to build one over the other. So material addition and material subtraction are complementing each other. We also have a laser-based cladding system. So laser and MIG will work together. That's the second level of hybridization. Initially, we started with plus and minus. Then we also went for the second level of hybridization. We also combine, 3-axis and 5-axis. Then we also combine different slicing concepts. So you can see that, we can have a hammer which will do the stress relieving. At this point, it may not be very clear because I cannot go into the depth of it. The topic is not really additive manufacturing. So this is just to expose so that those interested can contact me. So this is how the deposition takes place. MIG welding gun does the deposition on a 5-axis system. Okay, so I think I'll again skip it for the sake of time. So if we have to build an object like this, the outer side, we use laser because laser is precise, but more expensive and slower. Whereas MIG is very fast, but not very precise. So we use outside, we build outside using laser in multiple layers, and we also tilt it. Whereas once a container is ready, as it is here, out of laser cladding, then we dump using MIG cladding the filling material in 3-axis. So we are combining addition and subtraction. We are combining different energy sources. We combine different slicing strategies, and we combine different kinematics. This is our laser cladding system. Typically, laser cladding will use powder form of raw material. We bought this system from a German institute called Fraunhofer Institute in Dresden. So the wire will come from the center in a coaxial way, and through these windows that you see here, I think my arrow is visible, laser, a 4 kilowatt laser is trifurcated, and then it comes and joins at the substrate, melting the wire. So this is how it happens. Initially, we mounted it on our, this is the equipment, we mounted on our 5-axis machine. The 4 kilowatt of power of laser comes through this yellow cable, and then it uses so many other things to get the final cladding happening. Subsequently, we also thought of adding a multi-wire based system, because all objects that we use today, they are homogeneous in nature. Okay, whether it's a casting or anything, we would like it to be homogeneous, but in nature, no object is really homogeneous. Look at a bone, or look at a stone, or look at a wooden piece. Everything is heterogeneous, but it's not a random heterogeneity. It is designed for a purpose. So we are also thinking of adding one more station on this machine, in which there will be multiple wires. When these wires feed into the molten pool at different rates, we'll be able to get the heterogeneous object of the required nature. Okay, when we deal with additive manufacturing, it suffers what I call as a high aspect ratio, because at any time you deal in thin layers, that leads to warpages. As you can see from this figure, it leads to warpages. So you need to handle the residual stresses to minimize the warpage. So for the, you can see that because of the residual stresses, the component can actually crack, although it's a metallic part. So we need to avoid it. Now this residual stress is not only for non-living things. All of us, whether it is a plant or animal or we, all of us suffer residual stresses. That is why we sometimes say I'm in tension, sometimes we say we are under pressure. So residual stress can be tensile as well as compressive. So we do activities like massaging, singing, sport activities, all that, because we should avoid a catastrophic condition in which the residual stress releases itself. If there is a violent activity, that is because of this type of catastrophic release of residual stress. So we would like to release it ourselves in a voluntary way. So for for metallic components, we do preheating. You know, this is an induction heater. We preheat the substrate before we do the deposition. Is it from one of you? Hello? Hello? Yeah, I'm in a meeting. I'll call later. Yeah, I'm sorry. I thought it might be because of any audio visual problem. So I thought one of you might have called. So now this is a very interesting arrangement we developed. You see, it's a hammer. It's a pneumatic hammer. It does similar to massaging. It gives fine hits on the surface which may have residual stress. When this hits, it applies compressive stress. So it's very similar to the massaging activity. So massaging for metal. Okay, so that is why we have a very large system with multiple tool heads. Each one will have a different tool. One will have a camera, another will have a MIG cladding system, third will have a laser cladding system, fourth will have a preheating system, fifth will have the stress relieving hammer, and the sixth is presently empty, where we will add the multi-wire system. Now that is about the typical metallic manufacturing directly. We also developed a 3D printer here. It is for thermocol. We load a block of thermocol, and after some time we are able to get the thermocol piece. This thermocol piece can be converted, among many other applications, it can be converted into a metal casting using this as a pattern. We also have another project in which we developed a SLS 3D printer for sand. This particular mold was actually produced on this machine. From this mold, we were able to obtain this metal casting. So this is a 5 crore project in which about 25% is contributed by a private company. Same here. The machine was developed, and the foundry for this was a 5 crore investment, out of which 25% was given by a private company. Now, this is another very interesting machine, a 3D printer to print water, so that we are able to get ice objects. Now, you may wonder, what will I do with ice? We were able to get metal casting, as it is shown here, from ice. So we use ice as the pattern instead of wax, create a mold, and pour metal into it. I have a PhD student who has built this machine. He is writing his final thesis now. The latest two projects are on electron beam additive manufacturing. In fact, we don't call it as additive manufacturing anymore. We call it as hybrid manufacturing, electron beam hybrid manufacturing, because after depositing, we do machining and stress relieving every time. So it is more appropriate to call it as electron beam hybrid manufacturing. We have two machines under development, each about 5 to 5.5 crore investment. This again is contributed 25% by private companies, rest comes from government. So one machine is using powder as raw material, and the other machine uses wire as the raw material. Wire is typically meant for very dense parts and very large parts, whereas powder is meant for smaller components. Okay. So AMS in Bangalore is a partner here, and for wire, we have L&T in Mumbai as our partner. So there are a lot of interesting advantages of electron beam. I would like to minimize spending too much of time on it. One important advantage I would like to say is the scanning speed of electron beam can be as much as 10,000 meters per second, as against hardly 10 meters per second in laser-based additive manufacturing. So this extremely high speed is used not only for productivity, but for producing objects which are free from residual stresses. Lecture no? Okay. Bye. Okay, so this is used to produce matrices which will be free from residual stresses. We'll not go into the detail. Just remember that It's not just for productivity, but for producing a matrix which is free from residual stresses. I'll move forward. I'll close this part of it. I'll come to hydrogen mobility, green hydrogen mobility, where we like to produce hydrogen out of green system. And what we propose is a retrofitment approach. We'll take a regular diesel bus, remove the diesel engine, replace it with the fuel cell. Okay, that is one important change. The other change is we will replace the bottom rear axle by the E-axle. There is an electric motor. You can see that the electric motor is directly going to drive the axle and the power will go into that. So electric power will come directly rather than a mechanical power coming to this. So this is known as E-axle, electric axle. So we will simply replace the rear axle by E-axle. That's the second change. And the third change is we will remove all the diesel tanks, and at the top of the bus, at the roof, we will put several cylinders which will store hydrogen. Now, typically all hydrogen buses store hydrogen in cylinders at beyond 350 bar, whereas we propose storing at something like 30 to 35 bar. The reason is pumping hydrogen to higher pressure is very expensive and the pump is very unreliable, apart from the risk involved in the cylinder explosion. So we decided that we will have very low pressure. So it may be voluminous, but as per our calculation, the rooftop is sufficient to store the required cylinders for a travel range of about 200 kilometers. Here again, we are limiting these buses for urban mobility as city buses, because city buses do not require more than 160 to 200 kilometers of running every day over 2 shifts. So that's the thing. So these are some of the very interesting aspects of it. We focus on urban mobility so that the pollution is controlled. We propose a retrofitment approach rather than fresh buses. And we focus simultaneously on bus as well as the green hydrogen supply chain. And we propose to store on low pressure cylinders. So we will eliminate the need for a compressor, and we will completely replace, once the cylinders are over, the cylinders will, the bus will go and park under a crane, and the cylinders will be simply replaced. So this is the approach we are focusing, and we propose the same even for electric vehicles, because the electric vehicles hardly give 100 to 150 kilometers of running. After that, they have to be charged for anywhere from 4 to 10 hours of time. So there again, we are proposing a complete battery swapping system. So these are some of my research interests. So now I think I have to stop the sharing and go to another sharing because I was able to share only one PPT at a time. So this permits full screen sharing. I think it permits full screen sharing. Are you able to see my other PPT?
Yes, sir. Yes, sir. It's clear, sir.
Okay. Okay. Yeah. Okay. So now I'm coming to the actual topic. It's 10:48. I'll go till about 11:15. So I'm going to share with you my feelings of what is virtual and augmented reality. In this course, you have called it as augmented reality and virtual reality. In terms of hierarchical growth, first virtual reality came and then augmented reality. So I'll call it as V and AR. So virtual and augmented reality. I'll spend more time on virtual reality. So I'll start with the definition of virtual reality. Then I'll talk about the 4 important features of virtual reality. Finally, little bit about augmented reality. So I'll start the definition with the definitions given by some of the stalwarts in this field, about 30, 40 years ago. The first definition says the primary defining characteristic of VR is inclusion. So you see that people repeatedly use these two words, inclusion and immersion, to define virtual reality, because you are part of the environment which you are testing. Okay, so the word inclusion and immersion are very, very important. So this is the fundamental requirement in VR. The primary defining characteristic of VR is inclusion. Being surrounded by an environment, VR places the participant inside information. See, if you are creating a CAD model of a bus or any lever or any part, you know that you are clearly sitting outside it. You are interacting with it with a keyboard and mouse, and you get the visual output through the screen. Okay, it's a very simple method of doing design activity, where you know clearly at every time that you are outside and you are looking into the object through a rectangular window called a computer screen. Okay, so what we are doing in VR is far different from that. So the primary defining characteristic of VR is inclusion. Being surrounded by an environment, VR places the participant inside the information. This is one definition, a positive definition. The next definition is a negative definition. He says, what is not VR? Okay, so what he says is, indeed, in the ultimate display, one will not look at that world through a window, but will be immersed in it. So I told you, when you're talking about a regular CAD design or FEA analysis, you sit outside. Okay, you are looking at the results or the outcome through this rectangular screen. Okay, so, or a window. But he says that is not VR. VR means you should be inside it. You should experience it. If there is a fire, you should feel the heat of it. If there is anything else, you should feel that, rather than seeing it from outside. So this definition says, in the ultimate display, one will not look at that world through a window, but will be immersed in it. That means the third definition further amplifies it. It says, if I turn my head and nothing happens, it is not VR. So in this particular computer screen, I'm looking at this slide. Okay, whatever be the direction I look at it, it is the same information. It may have some distortion depending on the angle of looking at it, but information is the same. It has not changed. But when you wear a goggle or when you wear a head-mounted device, when I turn my head, I see a different scene. Very similar to the way when I turn my head in a classroom, I look at a different group of people for a different tilt of my head. So if I turn my head and nothing happens, it is not VR. So the next two definitions basically say what is not VR, and first definition says what is VR. Essentially, they all say that VR must have inclusion or immersion. You should be surrounded by the information. So based on this, I have come up with my definition, in which I say virtual reality is a more sophisticated, I use three keywords: real-time, multimodal, simulation. According to me, it's a simulation. Okay, virtual reality is a simulation with these two characteristics. It's a real-time response and it's a multimodal system. By this word mode, we refer to senses, multiple senses. We have 5 senses. Sometimes we say we have 6 senses, and animals have 5 senses. Okay, the number is for discussion later. We'll not get into that. Assuming that 5 senses all our existing CAD, CAM, CAE systems use only the sense of vision. Whether you create a drawing with plan, elevation and all that, or whether you write a letter, in all the things, what we deal is only sense of vision. We don't have other senses. Even sound is not used in your CAD activities. Only when we listen to movies or music, we have sound. Otherwise, when you talk about a CAD activity, sound is not part of it. So we deal with the sense of vision. So virtual reality tries to add more senses so that you are able to experience the environment in a more realistic way. So you are inside the environment and you are able to experience it in real time in a multimodal or multi-sensory environment. So that is virtual reality, real-time multimodal simulation. Okay, so what does it involve? It involves modeling the environment and then presenting it to the user. Now the environment may be existing or it may be imaginary. It may be an enemy territory which is not accessible to us, or it may be a new building which is still not there. Okay, you want to evaluate the building, you want to evaluate the airport before it is being constructed. So the first step is you have to model the whole thing in the virtual environment, and then you have to present it in some manner. If you look at an engineering drawing, you have multiple views of the object printed on a sheet. So it's a very rudimentary or very elementary way of presenting a three-dimensional object. As against that, if you wear a goggle and then you wear a glove and you see the 3D object, you are able to even touch and see how it is, then that is called presentation. So virtual reality involves a very sophisticated presentation of the model. So modeling is the first step, and then presenting it is the next step. Now, when you talk about modeling, we are not only talking about geometric modeling, because a typical CAD/CAM CAE system will have only geometric modeling. That means sense of vision only. But if you also want to include the sense of touch and sense of sound, then you need to model them also in it. We are still not very clear how the other senses can be modeled. So modeling is the first step. Presenting it in an appropriate way to give the feel of immersion is the second step. So then, apart from presenting it, it should also permit the user to interact with the model. How should the interaction be? It should be an intuitive or effortless interaction. Okay, when we are dealing with a typical CAD system like a SolidWorks, then if you want to rotate the object, you have a set of keys. Press the control key and then roll the middle button or things like that. Okay, so there is a set of instructions you have to remember and then execute in order to interact with the environment. Whereas in a VR environment, you want to feel included. So it should be intuitive and effortless. Okay, so we will see how it is done. What is the ultimate goal? Ultimate goal is to give you the feeling of immersion when you do the experience. Okay, so this is my definition of virtual reality. It's a real-time multimodal simulation. It involves modeling, presenting, and permitting the user to interact with it intuitively and effortlessly to finally giving the feeling of inclusion. Now, this intuitive and effortless interaction will require more sophisticated hardware for I/O. Simple mouse and keyboard is not enough. You need a more sophisticated hardware. That's what we are going to see here. Okay, now I'm going to list here the features of VR. According to me, these are the 4 important features of VR. You may be able to add many more, but these 4 are very fundamental. The first requirement is 3D display. Now, if you see here, I've used 2 words. Stereo is one word. 3D display is another word. What of them will do? 3D display is ideal, but we are yet to reach that in a commercial sense. So we are managing with stereo. Okay. Otherwise, 3D display is what we should really have. And the second requirement is real-time response. What is real-time response? You see the cursor here. As I move the mouse, the cursor immediately moves. There is hardly any perceptible gap or delay between them. That is what we mean by real-time response. That's why you see that the geometry of the mouse is made very, very simple so that few pixels are able to define it. So the refreshing becomes easier. You know, you must see, you should really visualize what all things happen to move the mouse from this end to the other end. The action we have done is moving the mouse by a short distance, but the computer goes through a lot of activities for removing it from here to here, because every time it erases the previous one, draws the next one, and as you move, it draws at different places along the path of it. Okay, every time it erases and then draws, erases and draws. And then you have something called persistence of vision. It has to rewrite the screen something like 25 to even 60 times per second. Okay, then 60 times per second for one eye and 60 times per second for the other eye. So you can think of the kind of refresh involved. If you say 60 is your refresh rate, then you have let's say 50 is the refresh rate, then you have hardly what 20 millisecond available for doing this refreshing activity. So by that time, all the calculations have to take place. So stereo display, for really real-time response. Third is intuitive and effortless interaction. That's the third requirement. And the fourth requirement is adding more sensors for the interaction, multimodal interaction. If we are able to get all of them, or at least some of them, we will have the feeling of inclusion or immersion. Okay. So this is these are four very important pillars or features of virtual reality. Now we'll go through each of these features quickly. I've already reached 11 o'clock, another 14 minutes available. So I'll quickly go through it. We have seen what is real-time response. I'll quickly say how it is achieved. You know, I'll skip this slide again. The very important thing is the time. You have very little time available. Let's say that refresh rate is 25. So for two eyes, you have a refresh rate of 50. That means you have to rewrite the screen 50 times. Let's assume that for first 20 milliseconds image of left eye, second 20 millisecond image of right eye, and alternately this keeps on happening. So within 20 milliseconds, you have to recreate the complete screen image. Each pixel has to be rewritten. Now for doing it, out of 20 milliseconds, you also have to calculate how much time it takes for the system to understand your viewing direction. Accordingly, the viewing transformation, all that has to be calculated. So you will have two cameras looking at your head movement, and then it has to calculate your head position and orientation. Then it has to calculate where you are looking at it. All that will require about 10 milliseconds, or you have to complete it within 10 milliseconds, because 10 milliseconds you need for the complete processing to take place, right? From, you know, hidden line removal, hidden surface removal, rendering, shadowing, and all that. So many activities are involved. Therefore, time is far more important here. Some sacrifice in quality is fine. That is what you see in the cursor's case. Cursor is always the simplest possible geometry. You know, sometimes they put circle rotating. The most irritating icon in Windows is the circle rotating, testing your patience. Sometimes people even put a horse running and all that. All that will add to the computing effort. Okay, so that is, so triangulation is the fundamental thing virtual reality does. It doesn't deal with very sophisticated geometry, but only simple triangular geometry. Then when you define an object, the object has two things. One is called geometry, other is called topology. Topology is how the entities are connected with each other. Virtual reality does not bother for topology. It only bothers for the triangles, which are basically geometry. Okay, then as far as possible, they try to make use of the hardware-based acceleration, and parallel processing is made use of. A lot of things like that happen. Now, when you deal with an object, the object itself is stored in at least 3 resolutions. You can see that a smooth object like this can be triangulated into a coarse way or very fine way. This will occupy less memory, this will occupy more memory. So when the object is closer to the user, this is used. When the object is farther from the user, this is used. So this is known as optimization with the level of detail. Ultimate goal is the number of triangles that you will be looking at should be minimized at any time. So optimization with the level of detail, which means you store multiple resolutions and then swap the models used at any time. Then there is another technique called view volume culling. You know, when I look at a particular direction, the environment may have thousands of objects, but when my direction is known, then what are the objects available in that direction only should be rendered. Other objects can be forgotten. This is known as the view volume culling. And then people pre-render for different color and light on spheres rather than the actual object. Then from the sphere, for a particular normal and diameter, they pick it up and then paste it on it. This is known as environment mapping. Like that, a lot of interesting, simple techniques are used to minimize the time required for computing. Now we'll come to multimodal interaction. There are as I said, sense of vision is fundamental requirement. Then we use a sense of sound. Sense of touch also is used, but typically in VR systems, we don't use a sense of smell or sense of taste, but people have gone up to the first 3. Now, when you talk about sense of vision, while we have only eyes, which is the input device, which is equivalent to camera in the VR system, we additionally need display. But in a human system, we don't have any display. We have only input, no output, because we are ourselves is the output. And each of the sense is also attached to another important characteristic known as latency. Okay, if an object stands in front of our eyes, in order for the eye to understand what it is, it has to stand there for certain time. And that is something like 125 milliseconds. So that is equal to 8 hertz. So normally latency is expressed in hertz. So 1 over that latency is represented in time units. So 125 milliseconds is the latency for eyes, but normally they go for even lower than that. Okay, when you talk about sense of touch, you know that human hearing is 20 hertz to 20 kilohertz. That's the range. And when you come to the device, in human beings or any animals, we have 2 devices, input as well as output. We have sound created by mouth, and the ears listen to that. So ears are the input devices, mouth is the output device. Mouth is equivalent to speaker and ears are equivalent to the mic. You will also notice that there is an anomaly of number. Typically we use 1 mic and 2 ears, whereas we have 1 mouth and 2 ears. I have a philosophical explanation of it, but we will skip it for the time being. Now, when it comes to sense of touch, this is really a tricky thing because of several problems associated with that. Number one, when you say sense of touch, it has multiple stimuli. You can take a needle and prick, or you can touch somebody, or you can slap somebody. So it could be force of very fine nature acting on a small area with higher magnitude, or over a higher area with small magnitude. This is pressure. Okay. On the other hand, you also may have to sense the temperature, the heat also has to be sensed. So multiple stimuli have to be sensed by the body, and the sensor has to be very, very tiny in nature. So that is on the geometric and number of stimuli part of it. Now coming to the speed, sense of touch is something like 1 kilohertz. That actually translates to 1 millisecond. That actually means that if somebody stands behind me and he contacts me, he touches me hardly for 2 milliseconds, I will be able to know that somebody has touched me. Okay. So it's extremely very precise or sensitive sense. So that again is the problem for its cybernetic implementation. For want of time, I'll skip the others. Okay, every one of these sensors are implemented in a digital computer by discretizing. There's something called divide and conquer algorithm. White light can be divided into red, green, and blue, RGB. That method is additive method that's used in computer screen, because the computer screen is black initially. So you add red, green, and blue in appropriate values, you get the required color. On the other hand, when you print on a sheet of paper, the paper is white. That means you have all the colors on the paper. So you have to only remove the color. So you do a subtractive way of mixing. So you use cyan, magenta, yellow, and black. Black is actually not the one. You have to only consider the first three. Black is to save the ink. Otherwise, you can mix these three to print black, but that will be expensive. Okay, now coming to a sense of sound, it is handled differently in computer system, but in human systems, we have 7 swaras, Sarigama Padanisa, and people also have different musicians and cultures have come up with different swaras. Okay, sense of touch, it is still an unexplored region, and the other 4 will not even bother for the time being, but we know that taste is already divided into 6 different tastes. Okay, we say Arusuvai. So all tastes are already classified for human purposes, but not for cybernetic purpose. So I think I'm taking a lot of time. So we have, this is known as haptic sensing. When we talk about sense of touch, it is known as haptic sensing. So there are several ways in which you can do it. You can wear this type of linkage system, or you can have a lever system, or you can have a tiny pneumatic cylinder attached to it in order to give you the sense of touch as an outcome. The input for sense of touch can be from the camera itself. Imagine that there's a wall in front of me. My hand is touching it. The camera can sense virtually where is the wall, where is the hand. It can calculate the interference. The moment interference is noticed, the hand should be prevented from moving further. So that type of moving further is prevented only with the help of this type of horrible devices like cylinders and all, which actually apply force. That means you are no longer in a virtual environment. So these are the reasons which are preventing the other senses to be implemented. You are not really in a simulated environment, you are in the actual environment. That way, sense of vision and sense of sound are reasonably easier. Okay, so now I would like to quickly talk about the devices used for stereo vision. are going to, you can have different devices. For example, if it is a big hall with 20 people experiencing it, then you will have a regular screen. On the screen, images of left and right eye can be projected alternately, and then you can have some kind of goggle which will filter out the image of the other eye. So imagine that left and right images are put on the screen alternately. When the left is on, your left goggle is open. When the right is on, the right goggle is open. Like that, this keeps on happening alternately. There are several devices available. Again, I'll skip this video for want of time. Now, subsequently, people went for horizontal display. You know, what you saw in the previous slide was a vertical display. It is meant for many people, like 20, 30, even 500 people together. But subsequently, people try to use it for medical applications where the patient is lying in an unconscious state and surgery happens. So when they tried it for this, they had to have a horizontal display. Subsequently, people realized that this is also useful for other engineering applications. For example, you can see here, this is a horizontal display, and what he is holding in hand is the representation of the car he is designing. So you can see the intuitive way by which he is able to rotate the car. He simply lifts the car and rotates, it rotates. Okay, so he's in space drawing something that results in the required surface for him. This is what we mean by intuitive interaction with the device. Then subsequently, they thought the amount of information you throw on one wall is not enough. So they went on adding multiple walls. So they could go as much as 6 walls surrounding it. Most of the simulators for flight, or even I've seen a simulator in CVRD in Chennai, they simulate the tank, the battle tank. You know, I sat in, and then they showed me. We were able to comfortably go inside water and, you know, drive in the forest area with rough terrain and all that. That gives a beautiful simulation where it also adds the shaking using a Stewart platform. Then there's something called a cave. And this becomes for individual experience. This is known as a head-mounted device, where you have one CRT for left eye, another CRT for right eye, and images are correspondingly projected on them. And because it is CRT, it is quite heavy. Then it could be as heavy as 5 to 10 kg. So people thought, why not? You know, it will be compressing. You can't wear it for more than 10 minutes. Then they thought they will put it on a stand and then maneuver it by hand. This is known as boom. But subsequently, boom became unpopular because from CRT, people went for LCD displays. Now, this is a very, very interesting device, which is for augmented reality. Now you see there is one CRT on this side, another CRT on this side. He is wearing a regular goggle through which he will be able to see the real world. Now there is a small prism on both glasses. So the image going from this gets diverted by 90 degrees and then goes into it. So the CRTs on the sides will have the image of left and right projected on it, and it gets into the eyes. At the same time, he's also able to see the real world. That means you are able to mix the real as well as the virtual objects together. This is known as augmented reality. You are augmenting a real world with the virtual images. Okay, so this was first tried for pilots who are going to bomb the enemy territory. So using a previous reconnaissance mission, they fly over the enemy territory, take photography, which could be even stereo, and they also along with the same track, record the geographic location using GPS. Now that information is kept in the ground, and the ground commander will be playing it on through these to the pilot, which is synchronized with the flying geography of the pilot. So the pilot is seeing the actual territory, and the commander is superimposing it either with the image, or he simply uses a cursor to point at which building the pilot is supposed to bomb. So he does it. So this is a beautiful way of mixing real and virtual information together. The virtual information need not be the 3D geometry. It could be as simple as a cursor. Okay, so I have to move a little faster. So these are, I would probably, show this particular video. Typically you need a goggle to see the 3D information. Here we have a very interesting device where this fellow winks his eyes at that rate. Imagine that on the screen, you have the information of left and right eye alternately presented. So all you need to do is, for first 20 milliseconds, keep your left eye open and wink the right eye. And for the second 20 millisecond, you repeat it, alternate it. But then it is humanly impossible. We cannot wink at that speed. Try it. Try the maximum possible winking speed for you. It can be hardly 500 milliseconds, but you want it at 20 milliseconds. How to do that? He has developed a device which will do that. He attaches two devices on his temple. That temple device basically does a pricking of the temple. When your left temple is pricked, you close your left eye. When your right temple is pricked, you close the right eye. Now this pricking frequency is synchronized with the display of the thing. So we'll see what he does. So this is an augmented way of winking. The device helps you wink faster. See his eyes. So his winking synchronizes. When you see this video, immediately don't bother what will happen to his eyes. Is it good for health and all that? Let's not worry about it, because this is an idea. Okay, had it been successful, it would have been already in the market. It is not yet. Okay, but idea is very, very important. When you see an idea, you should not evaluate it. Evaluation is done later. But it's a very, very innovative way of doing things. Okay, so there are several IO devices used. I would like to probably skip this. I'll quickly show the devices. We have this is a virtual torch, and this is the CAD model of an Ajanta or Ellora cave. And this cave is actually from Chinese region. Dunhuang is the place. So the virtual model is created, and you want to experience as if you are walking in the cave with a torch in hand. So this is the computer screen, and this fellow is standing outside the computer screen, and this is not real torch, but a pointing device. So when he presses the device, the computer is activated to create a spot-like environment in which the statue is visible. So this is a specially designed input device. Like that, you need special IO devices. I already told a little bit about augmented reality, but I would like to talk about a very, very important application which is used in brain surgery. See, you have virtual and real environment in VR as well as AR, because you as a real person is visualizing an object inside a computer screen. So you are real and the computer screen image is virtual. So when two scenes exist, real and virtual, you need to align them. Okay, this aligning is done using the overhead cameras in the case of AR, which are not very accurate. So the alignment is not very important, but the alignment is to the extent of identifying roughly what is the angle by which the head has moved or the torch has been held. So the alignment accuracy is not very high. But when you talk about a brain surgery, I'll explain the brain surgery. The patient has a tumor. So a few days ago, before that, they shave off the head. They mark using special ink, a grid. In this condition, they do the MRI. When they do the MRI, the complete brain area along with the tumor and other defects are captured. And at that time, this 3D image of the grid we have drawn also will be part of it. So you have it in the virtual environment. So you can visualize this virtual thing as a marker. Okay. So when the doctor actually wants to do the surgery, he cannot now use the overhead camera. He will actually use the virtual grid to align with what he is really seeing. Okay. So he will have this type of arrangement. So he will see virtual as well as the real image. So for him, the virtual and the real grid will be first aligned. Once these are aligned, then the virtual tumor and the real tumor will also be aligned. When he opens up the skull, he will not see the tumor popping up separately. It will not be looking as shown in this in a different color. It will be covered by blood, mucus, and various fluids. And so he will have to use his experience to scrap it out. So that is why, if we have this type of arrangement, the virtual reality system will nicely highlight what is a tumor so that he can very precisely cut away, because you can't cut away the nearby active brain part of it because it may damage his functionality. So this is one of the interesting applications of augmented reality in brain surgery. All I want to highlight here is the registration or alignment of virtual and real images is far more accurately to be done in an AR environment than VR environment. In VR, it is just to give you the feel of realism. Whereas in AR, you are going to do a robotic surgery subsequently, therefore it has to be aligned perfectly. Other than that, not much difference. Okay, so I'll come to the conclusion slide. As we discussed, there are the ultimate goal is to get a feeling of immersion or inclusion. And we have seen that there are 4 features which help in that. One is the 3D or stereo display. Second is a quick response or real-time response. Third is you will interact with the environment using special IO devices so that the interaction is intuitive. Okay, and the fourth is, if possible and if necessary, if justifiable, we can add other senses like sound and touch. As I said, sound is easy, vision is easy, but sense of touch and other senses have more difficulty because you are actually not in a virtual environment. You are experiencing the stimuli directly. That is one. When you talk about sense of touch, within a given small area, you need very tiny sensor. At the same place, you have multiple sensors because the stimuli are different. You have to sense temperature, you have to sense pressure of different kind. And apart from that, to complicate it further, the time available for doing any sensing is very less in sense of touch. So they are still emerging and not yet very popular. So with this, I would like to conclude my presentation. I thank you all for the patient listening, and I thank the organizers for this wonderful opportunity. I'm very sure over a period of time, we'll get used to this kind of presentation, online presentation. And very soon bandwidth will improve. 3D displays will come so that we can all see each other in 3D and then interact in a much better way. So with this, let me conclude. Thank you very much. If you want, you can shoot this slide for our communications.
Thank you very much, sir.
I'm done. Please go ahead.
Yes, sir. Thank you very much, sir, for your kind, wonderful presentation. Very interactive and very informative and very educative in this rapidly emerging field. Now, I request all the participants to, if you have any queries, you can either unmute yourselves or you can post the questions in the chat box to the participants, because the session has to be interactive. If you have any queries, you can unmute yourself, and or either you can send the question in the chat box. Thank you.
Sir, to coming to the augmented reality or virtual reality, is this will be required any internet specification like a 4G support or 5G support or like this?
See, today the internet speed may be very, very low for 3D interaction.
Yeah.
So it is better to have it within the same room only.
Okay.
Today's internet speed is too low to permit, even I know sometimes direct video chat becomes difficult and we close the video.
Okay.
So I don't think today's speed is adequate, but I'm very sure things will improve. Or, you know, some places have direct connectivity. For example, in IIT, we have 200 Mbps speed. Because we have a direct connection for getting. So many of the IT organizations have dedicated connections with very high bandwidth. There it is possible. If you are talking about common public like us, existing speed using data pack or even your broadband, word is broad, but still not broad enough for VR applications or even AR applications. So I think we have to wait for some more time.
Okay. Sir, when it is coming to virtual reality, so when it's coming to here, so we have to maintain that some goggles type or some specific device, and there we can already with the using of those kind of goggles or specific viewing system, or we can monitor in the form of real images. That is the right.
Okay.
Sir?
Yeah.
Yeah.
I mean,
So
goggles are available.
Yeah,
they are available nowadays, very cheap. I could not go into the details. There are two types of goggles available. One is a passive goggle, which is nothing but a colored glass, or it's a polarizing glass. You know, left and right glasses may be of different polarization. You know, polarization has different angles. Okay, so these are passive and very cheap. You can get it for if you mass produce it for 10 rupees, you can get a goggle. That's what you see in all 3D movie halls. So those goggles can be used, but active goggles, again, they are not very expensive because they basically have two displays. For example, for welding, we have bought one recently. It costs hardly 1,000 rupees. So for VR application, you will get even for 500 applications if it is mass produced. So these are readily available.
Okay, sir.
Is this a question, or I have not got it correct?
Yeah, that is only. So this by
it's readily available.
Okay.
And a lot of downloadable software is available for VR implementation.
Okay, is this required any coding language? Is it required, sir, to make it?
Typically, we normally use C hash. C
Okay.
hash is the top end of C++ programming. We started with C, C++, and all that. Today, C hash is popular.
Okay. Okay, sir. Sir, when it is coming to augmented reality, so to make that one if I want to make it one AR setup in my home, so I need to require how many direction means if you are referring for the AR five direction means 5 cameras it is required to make that 5 angles X, Y, Z, A, B, C, like that for the each and every angle.
You need only 2 cameras.
Only 2 cameras.
Yeah, 2 cameras. See, the way we have 2 eyes.
Okay.
2 eyes give you 3D feel, right?
Oh, yes, sir.
Same way, 2 cameras are enough at fixed location. They will be in fixed location and you will calibrate it a priori. Then the camera will be able to tell where the object is turning and all that. 2 eyes are enough.
Okay, sir. Sir,
similarly, 2 cameras are enough.
Yeah. Sir, I will tell that one example. Is that really direct practical AR? Just to confirm me, I will take that one movie example. Have you seen that Iron Man 2?
No, I don't see too much of movie.
Sorry.
But
actually, yeah, some clipping.
There was a
in the clipping. Yes, sir. Yes, sir.
I've seen 3D movies where goggles are worn and seen.
No, sir. In that one, in that movie, I mean, the guy, hero guy, he want to monitor that all the he put that one map around the system. He have the one map, that's a reactor map, how it will be Silicon Valley, like that. It is map. It is there. So there he will tell that some his AI system to artificial intelligence system, scan the judges, you scan that entire thing, like that. He will tell that one. After that, he can pop up that entire that images, and inside that one he will enter that one. So everything it will project around him, and he will go and touch that every iconic that one. You can expand means it will by how we will be expand that our mobile, right? Like that he will click on and he will expand and he will throw, he will move, like that it will do. Is that that way? Is the I'm asking like that? Is that way? That is the AR picture going to be in the practical scenario?
See, AR is a mix of physical and virtual information.
Okay.
Okay, I gave 2 examples. One is the pilot shooting.
Okay.
Okay, the commander from the ground pointing out which building he should shoot.
Okay.
So in that, the cursor he will show or the image he will project will be virtual, but the pilot is actually seeing the actual thing. Same with the brain surgery. The doctor may not really see the real tumor. He will look at the virtual tumor, but his knife is real.
Okay. Yes, sir. Yeah, I hear that this kind of thing for the appendicitis operation, now people are following. This is the way, right?
Yeah.
Robotic arm will be go and it will become, but from here, computer, he will be operated. Is that the example for the?
This is actually a mix of robotics also. The endoscope device, it is nothing but a robotic device, right? A tiny hole is made and then it goes into the body, and then it also has a bulb, it has a scissor-like thing to cut away the things. So this is a robotic plus augmented reality application. This type of medical application is far more complicated. They are really an advanced field.
Okay, sir. Okay, sir. Thank you, sir.
Yeah, we'll interact further. You can feel free. Huh?
Yes, sir. Yes, sir. Thank you, sir.
Sir?
Yeah.
I have few questions, sir.
Yeah.
May I know your ideas or views on holographic projections or instructions versus VR AR, sir?
Repeat again, please.
May I know your ideas or views on holographic projections or interactions versus AR VR, sir?
Oh, holography, are we talking about on a film or on a dynamic environment?
A dynamic environment, sir.
If it is a dynamic environment, holography is 3D display. 3D display. Now I talked about stereo display and 3D display. Stereo display is a compromise because what you have is a screen which is 2D. On the 2D screen, you put image of left and right alternately. So that is a compromise. But 3D display is very similar to holography.
Yes, sir. But what is the delay on getting holography projections with this technology, sir?
Now, if you are that is also virtual display, so it will be really fast. Holography, if it is it is online, then that also can be very fast. But it is yet to develop, unfortunately.
Okay, sir. So why the 3D printing is not standardized yet, sir?
Nothing has been standardized in life. See, standardization and dynamism are opposite to each other, isn't it?
Yes, sir.
See, the people at different times develop different things. There are also proprietary nature. Okay, so today electric vehicles are coming. I saw our Mumbai bus service. They bought electric buses from 3 different sources, and for each bus you have to buy a different charger. Okay, isn't it true with even in your mobile phone? Only now the connectors have been standardized. Otherwise, in those days, you have to buy the charger and connector from the same company, isn't it? Standardization has 2-3 aspects. Standardization may kill their market. So people deliberately, in order to hold on to their proprietary nature, they do that. Okay. Sometimes because of the differences in time and space, also standardization is lost. For example, you look at the jewelry industry, the thread used on all the jewelry are left-hand thread. There is no reason why it should be left-hand thread. It could be right-hand thread. Whereas in all engineering field, we use right-hand thread. This is again a thing. Same with metric system, and the Americans are very comfortable, expressing in gallons even now. They still use foot and inches instead of the metric system. So there are vested interests, there are space and time related issues because of which standardization lags behind. Otherwise, there's no doubt that standardization is required.
Yeah, okay, sir. And could you please put forward some of the challenges faced during your drone project, sir?
Which project?
Drone.
Drone project. Yeah. It is never ending challenge only. Because right now battery is the problem. We don't understand battery. I'm a mechanical engineer, so we don't understand battery yet. So we need help. We don't have anyone who can really advise us on that. So I'm in touch with even Mahindra and Mahindra, but everybody looks for a business. The support is very poor when you want to develop a prototype. Everybody says order 10,000 pieces, we will develop it. So battery is a problem, and we basically don't want to get into the fundamental development. In product development, if you want to develop the product very fast, you should not get into the fundamental component development. We try to remain at system development. For example, if you look at the propeller, it's a 1 meter diameter carbon fiber propeller, graphite FRP. That itself is a technology by itself. So we would like to buy it. Same with motor, we buy it. Controller, again, we buy it. We only try to configure it. We try to calculate how much lift we need and basic specification. Then we try to choose the thing. So more of outsourcing. Now, even if we succeed in battery-based system, right now we have 8 minutes of time, and because of poor use of it, abuse of it, we have already spoiled half of the batteries. We have hardly flown for maximum 30 minutes of continuous time, but half of the batteries are gone, about 2.5 lakh is lost. So we don't understand battery, we don't get the knowledge. So we have to do everything ourselves. So wherever things are not readily available, we have to read up a lot. Now, even if I do it, I can never get more than 25 minutes using batteries. So we have to look at hybrid power. So you still should use fossil fuel like petrol. So we are buying a petrol engine, then convert it into electric power. So a lot of challenges. We are nowhere closer to the goal. What we make is very, very baby steps, and I really don't know how long it will take. But then the whole process gives you kick. At least we have started the exploration, more people will follow it up. The only thing we try to do is we keep everything open. I'm not particular about any kind of IP. Whatever I have done, I can even share the CAD model. People can continue.
Thank you very much, Rahul. Now, thank you, sir, for your wonderful presentation and patiently answering queries. It has been an eye-opener.
We'll interact. We are running short of time, unfortunately. So yes, we can close if you want. Okay. Very nice. Thank you for inviting and thanks for the opportunity.
Thank you very much, sir.
Good luck to all participants.
And I would request now Dr. K.R. Vijaykumar, sir, to propose the vote of thanks.
Good morning, one and all present here. It gives me immense pleasure to deliver vote of thanks for this AICT Atal sponsored 5 days national level faculty development program on augmented reality and virtual reality. On behalf of Department of Mechanical Engineering, I am proud to extend my sincere thanks to the Chief Guest, Dr. K.P. Karunakaran, Professor, Department of Mechanical Engineering, IIT Bombay, for his wonderful special address. I also extend my sincere thanks to Vice Chancellor Dr. S. Geeta Lakshmi for her inaugural address. I express my sincere thanks to Founder Chancellor Dr. A.C. Shanmugam for his constant support. I wish to express my deep sense of gratitude to Engineer A.C. Kumar, President, for his constant support and encouragement to conduct such event. I would like to acknowledge our gratitude to Registrar Dr. C.P. Palnivel for constant engagement and support. I am also very grateful to Dr. M. Ganesan, Joint Registrar, for his felicitation address. I express my sincere thanks to our Dean END and HOD for their continued support and encouragement to conduct this event. I also express my warm gratitude to all my colleagues for their continued support to make this event grand success. I would like to acknowledge AICT Atal for sponsoring this FDP for augmented reality and virtual reality. Last but not least, I thank all the participants for making this occasion grand success. Thank you.